examples if I counted correctly. But we'll go through a bunch of stuff here and hopefully help you understand what you're supposed to do and how you're supposed to get there. So let's start off with factor of polynomial, and let's review factoring with synthetic division. We did this last week, so I want to kind of start out with that kind of thing this week and get our brains back going around that. So we got 3x to the 5th minus 2x to the 4th plus x cubed minus 8x squared plus 5x plus 1. And they're going to tell us that x minus 1 is a factor. So they give us this hint that x minus 1 is a factor out of that. So we kind of did this a little bit last week when we were doing synthetic division. We answered the question, is that a factor? In this case, they're telling me it is. Okay, so what I want to do is I want to use synthetic division to break that polynomial down a little bit with that x minus 1. So I'm going to set up synthetic division for this polynomial. So I've got 3, -2, 1, -8, 5, 1. Didn't have to put any zeros in there because I didn't have a missing piece. It started with x to the 5th power. I had an x to the 4th power, 3rd, 2nd, 1st, and then a plain number. So I didn't have to put any zeros in there. Remember, if there is something missing, you got to put a 0x or 0x cubed or whatever's missing in there. Now, to get the number on the shelf, remember, you take what the factor is and set it equal to 0. And so I get a positive 1. So that positive 1 is what goes on that shelf. Okay, so when we run this, because they told me that x minus 1 is a factor, then I know that the remainder for this should be 0. That was the remainder theorem from last week. It told us that's what happens when it is a factor, is that the remainder is 0. So I'm going to run synthetic division. So the first step, if you remember from last week, the first step to synthetic division is drop that 3 down. And then you're going to multiply 3 times 1. And then you're going to add that column up. -2 plus 3 is positive 1. Then you're going to multiply again. 1 times 1 is 1. Then you're going to add that next column. So that's 2. And then we're going to multiply. 2 times 1 is 2. We're going to add that column together. So -8 plus positive 2, it's going to be -6. Then we're going to multiply -6 times 1. That's -6. Then we're going to add those two together. 5 plus -6 would be -1. -1 times 1 is -1. And then add those together. There's my 0 in that remainder spot. Okay. This is what we did last week. We did this synthetic division, and what it does is it takes that polynomial and it breaks it apart into that x minus 1 factor, and then this quotient, that 3, 1, 2, -6, -1, that quotient becomes the coefficients of the polynomial that's left over. And synthetic division always takes our polynomial down 1 degree. So we started with an x to the 5th power. We're going to go down. This is going to be 3x to the 4th power. Okay, so 3x to the 4th power plus 1x to the 3rd power plus 2x squared minus 6x minus 1. Okay. So that synthetic division, because we knew that x minus 1 was a factor, it factored that polynomial and broke it into one small piece and then one pretty large piece that we would have to do some more stuff with. Okay, so this is just reviewing what we did last week. Okay, just reviewing what we did last week. All right, now let's take a different polynomial and then let's try to do the next instruction that they give us in this section, which is factor the polynomial completely. So that isn't just doing synthetic division the one time and stopping. That's taking the polynomial and trying to break it into all of the smallest parts that you can. Okay? So here's our example. So we'll get us a slightly smaller polynomial to break apart here. So here's our polynomial. F of x is equal to 6x cubed plus 19x squared plus 2x, bless you, minus 3. And they're going to tell me, so there's a semicolon, and they're saying x plus 3 is a factor. Bless you again. Okay. So we're going to break this polynomial into all of the parts that we can. So we're going to try to factor it. I'm hoping that we end up with 3 little sets of parentheses when we get done here. Okay. So I'm going to take that polynomial and I'm going to set up, because I know they gave me this clue here. So right now, they're giving me some hints to help me. Later on, we're going to take those hints away and we're going to have to come up with them on our own, and I'm going to teach you how to do that. Okay, so right now they're giving us this hint that x plus 3 is a factor. So that tells me when I do synthetic division, 6, 19, 2, negative 3. And then I take x plus 3 equal to 0 and subtract 3. So negative 3 is what goes on the shelf. So when I do this synthetic division here, they're telling me that my remainder should be 0, because they said x plus 3 is a factor. So that remainder should be a 0. So I'm gonna run synthetic division on that. Drop the 6 down. 6 times negative 3 is negative 18. That's a 1. Negative 3, that's a negative 1. That's a positive 3. There's my remainder of 0. Okay. What that did for me is it took my polynomial from that x cubed thing at the beginning, and it took that polynomial and it broke it apart into x plus 3 times 6x squared plus x minus 1. Just remember, synthetic division takes you down 1 degree. So we started with x cubed, so our quotient is going to be x squared. So that's where the 6x squared came from. We started with x cubed up here, and when we go down here, this becomes an x squared. Now I've got a quadratic right there. That's a trinomial. So I'm going to try to factor that. So this is where that x method thing comes back that we've been practicing a little bit in labs today. That was kind of the whole point of us practicing that sum. So I'm going to multiply to be negative 6, add to be positive 1. 3 times negative 2. All right. Now, I can't take my shortcut on those factors because it has that 6 in the front. So I've got to do the long grouping thing. So I got a 6x squared. I'm going to put plus 3x minus 2x minus 1. And then I'm going to group that together. First two together, what's the GCF of that group? 3x. And that'll leave me 2x plus 1. And then what do I factor out of the second group? Negative 1. Very good. And that leaves me a 2x plus 1. So my factors now are x plus 3. That was the one they gave me. And then I have the 2x plus 1 and the 3x minus 1. That, folks, is our factored form. So getting that factored form, well, what good does that do? Well, what that allows us then to do is get the zeros of the polynomial. So we factored it completely. We got it down to its smallest parts. And then what we do in section 3.4 is we find the zeros. So the 3.3 is the factoring part. 3.4 is the zeros part. So let's go ahead and do that. Since we got it factored, we did all the hard work to factor it. Let's go ahead and find the zeros. So the zeros were we're going to set f of x equal to 0. So we got x plus 3 times 2x plus 1 times 3x minus 1. We're setting that all equal to 0. And if we've got it factored, all you got to do is set each factor equal to 0 and solve it. So subtract 3. That's going to be x equals negative 3. Subtract 1. 2x is equal to negative 1. I'm going to divide by 2. X is negative 1/2. The last one, I'm going to add 1. And then divide by 3. I got positive 1/3. Those are the zeros of my polynomial. The zeros of the polynomial, another name for those are x-intercepts. Zeros and x-intercepts are the same thing. If they're real numbers, if they're complex, they're not x-intercepts, they're just zeros. But these are all real numbers. Now here's the cool thing. If I graph that polynomial, I'm going to go back to the original. What was the original? 6x to the third plus 19x squared plus 2x minus 3. I'm going to hit graph. I'm looking for zeros. So where's it crossing the x-axis at? I see it crossing at negative 3. That's right there. That one is a negative, but it's about halfway between 0 and negative 1. That's the negative 1/2 right here. This is the positive 1/3 right there, where it's crossing the x-axis. And if you hit trace on those, if you hit trace negative 3, that's that spot. We'll hide my negative 3, 0. Right here's the negative 1/2. Negative 1 divided by 2. Boom. There's my y equals 0. That's a 0. Then 1/3. 1 divided by 3. Boom. There's 1/3 as a decimal. There's the 0 in the y. So by factoring, we're able to find those places it's crossing the x-axis. Now, could you eyeball if that's 1/3? I don't know. I mean, it'd be hard to, because what's the difference in 1/3? Like when you're looking at that screen, 1/3 and like 2/5 are pretty dang close together. So it'd be hard to tell without doing a little bit of work out of that. So being able to check that with the graph and do it the factoring, that all ties together. Okay, so the idea is that you tie it together. You use the graph to help you kind of verify some stuff and make sure you're on the right track. Let's try that with, there we go, example C. So let's try example C here. Same thing, factor completely, and then we're going to find the zeros. So here's our function. G of x is equal to x to the third power plus 4x squared minus 5. And they're telling us that x minus 1 is a factor. Okay, so x minus 1 is a factor. And then we have this x to the third power problem that we're going to try to break this polynomial apart. So I'm going to set up synthetic division. What goes on the top row here? 1, 4, 0, negative 5. Why is there a 0 there? Missing a plain x. So we're missing a piece. So we got to put that 0 in the place of the plain x that wasn't in the problem. Okay. What goes up on the shelf? Positive 1. Yeah, positive 1. And if you're unsure, if they give you that factor, set it equal to 0 and solve it and get x equals 1. That's what goes on the shelf. Then run that through with synthetic division. Do the work. Drop the 1 down. There's my remainder of 0. So what does that factor as? That factors as x minus 1, x squared plus 5x plus 5. That's what one polynomial has factored at using that synthetic division. The next thing that I want to do then is try to factor that quadratic, if it will. Quadratics don't always factor, but sometimes they do. So I'm going to try to do the x method. What multiplies to be 5 and adds to be 5? Well, what multiplies to be 5? Well, 5 times 1, but that adds to be 6. That's not right. What about negative 5 times negative 1? That adds to be negative 6. That's not right. That's the only things that multiply to be 5 other than decimals and fractions, and we don't want to entertain that idea. So that doesn't factor. So this is my factored form. That's all that'll happen to that one, is it factored as much as that synthetic division was the only factoring that could happen. So that's my factored form. So if they ask for the factored form, that's what they're looking for. Now, if they ask for the zeros, we're taking x minus 1 times x squared plus 5x plus 5. We're setting that whole thing equal to 0, which means you take each factor. So I'm taking x minus 1 equal to 0. I'm taking x squared plus 5x plus 5 equal to 0. And we're solving those. So this one's the easy one. You get x equals positive 1. We already know that x squared plus 5x plus 5 will not factor. We tried to do the x method, it won't factor. So what's my only way of solving that? Quadratic formula. So I'm doing x equals negative b plus or minus the square root b squared minus 4ac divided by 2 times a. Okay? Same thing we had done in lab tonight. We did that stuff on purpose, okay? So that we can get some practice with it. All right, so we're working that out. So negative 5 plus or minus the square root of 25 minus 20 is 5 over 2. And that doesn't break down any further. I would write it like this: negative 5 over 2 plus or minus radical 5 over 2. That's how I would write it. I think that's how they'll write it on the final and probably on Canvas and stuff. That's how they'll usually write it, is like that. So there we have one that factored with the synthetic division, but then what we had left over didn't factor any further. We had to use quadratic formula. So that's a thing. That's just part of this, because not every quadratic factors. Sometimes they don't. We got to use quadratic formula to help us. Okay. All right. Questions about example C there? All right. They're still giving us hints, so we hadn't took away the hints yet. Example D, they say f of x is equal to 2x to the third power minus 3x squared minus 5x plus 6. Okay. And then this time the hint is 1 is a 0. Okay, so they changed up how the hint was written. They told us that 1 is a 0. So that is the same thing as if they had said x minus 1 is a factor. Those two say the same things. 1 is a 0 and x minus 1 is a factor. Say the same things. We've got to tie that together. Now, If this says the same thing as that, then I'm doing it the same way. I'm going to take synthetic division and get rid of that x minus 1 or factor it out. So I'm going to set up my synthetic division. I'm going to put 1 on the shelf. I got the 2, -3, -5, and 6. Now I'm going to run synthetic division on that. I should have a 0 in the remainder spot. If I don't, then that's my fault. I did something wrong. Okay, that remainder's got to be 0 because they told me that it was a 0, that 1 was a 0. So I'm going to run that through. 2 be -1, that's -1, that's -6, and there's -6. There's a 0. Yeah, it worked out. Great. That's wonderful. Now, what does that do as far as the polynomial goes? It breaks it apart. The factor, when 1 is a 0, the factor is x minus 1. So I got x minus 1, 2x squared minus x minus 6. So I've factored out the x minus 1 using synthetic division. Now I'm going to try to factor that quadratic and see if it'll break apart. It might not. We're going to try to see if it will. So I'm going to do the x method. What goes on the top of the x? -12, and then -1 goes on the bottom. -4 times +3 does do that. Now, I can't take the shortcut on that factoring. I've got to do the long way. I've got 2x squared minus 4x plus 3x minus 6. And I'm just writing them in there, and I'm grouping. First two together, the GCF of 2x squared minus 4x would be 2x. That leaves me x minus 2. And then the GCF of 3x minus 6. 3. Where 2 times -6. Always the first term, the number in front times the number in back. That's how you get the top of the x. Always. 2 times -6. That's the -12. The -1 comes from the number in the middle. And then, so that's how we get the -4 and the 3. Group, and then group, and there's the +3 that we're pulling out of that. So now my factors, I got the factored form now. I've got the x minus 1 that we did with synthetic, and then I have the x minus 2, that's the matching parentheses, and then the last one is the 2x plus 3. So there I finally have my factored form. If you can get the factored form, the zeros are the easy thing. But the factored form is the hard part. Takes work to get there, a lot of work. Takes practice. So let's set those to get the zeros. I'm just setting each factor equal to 0. Getting x by itself. X equals 1. X equals 2. This one's got a little bit more work. It's 2x is equal to -3. And then divide by 2. -3/2. If I graph the original problem, I'm going to see it hitting the x-axis at 1, 2, and -1.5. So I'm going to show that. I'm going to graph x to the third. Nope. That's not the right problem. Sorry. That was the one before that. 2x to the third. There we go. Minus 3x squared minus 5x plus 6. And I'm just going to hit graph. We should see that hitting the x-axis. There's my positive 1. There's my positive 2. And then this is negative 1.5 or negative 3 over 2. We can verify the zeros we find by graphing it. All right. I know this is challenging. This puts together a lot of things that we've done, and that's when it gets harder, when you got more things to remember how to do. But the more practice we get with this, the better. So let's do one that has a fraction given to us. Okay, so let's go here. Make sure my video is still going. It is. Okay. All right. So let's say we had example E. It says f of x is equal to 4x cubed plus 6x squared minus 2x minus 1. And 1/2 is a 0. So they gave us a fraction that as one of the zeros. And we've seen on the previous problems where we had some problems where one of the answers we found was a fraction, and that's okay. So, but this time they gave us that, so that's what we've got to use in synthetic division, which is going to make this seem a little harder, but it's really not. It works out real nice with this one because the numbers are all nice there in that problem. So I'm going to set up synthetic division with this problem. I'm going to put a 1/2 on the shelf. I've got the 4, 6, negative 2, negative 1. Don't need any zeros because I had one of everything from x cubed on down. I didn't have any missing pieces. We're going to run synthetic with that 1/2. So I'm going to drop the 4 down, and then I'm multiplying. 1/2 times 4. What's half of 4? 2. That's easy. Okay. Then add those together. That's 8. And then 1/2 of 8 is 4. And then negative 2 plus 4, 2. And then half of 2 is 1. And there's my remainder 0, which I expected to be a remainder 0 because they told me that 1/2 was a 0. If I got anything other than 0 there, I know I probably made some sort of arithmetic error. I must multiply it or misadd it somewhere. Now, here is a little bit of detail here on the synthetic division. If all numbers have a common factor, divide by it. So here we have a 4, 8, and a 2. All of those numbers are divisible by what? 2. So go ahead and divide by 2. If they were all divisible by 3, I'd divide by 3. That 2 has nothing to do with anything else. It's just looking at these numbers. When you do synthetic division, especially with a fraction, that's when this happens. It's when it comes up sometimes. Okay? So if all those numbers are divisible by something, divide by it. Okay? Now, here's what happens. That gives us a quotient of 2x squared plus 4x plus 1. What is the factor that came from the 1/2? That's the 2x minus 1. Why does it have to be 2x minus 1 and not x minus 1/2? If you were to multiply that back together, the original problem has a 4 in the front. So what times this 2x is going to get me that 4? That's got to be a 2, right? That's the way that works. When you have that x equals 1/2, if you multiply by 2, that's your 2x. And then you subtract 1, that's your 2x minus 1. That's working backwards from what we know x is equal to into getting that factor. If you'll just remember, the shortcut is whatever the denominator is goes in front of x. Whatever the numerator is, subtract it from there. That's the shortcut to getting that factor. So like if it was 1/4, it'd be 4x minus 1. If it was negative 2/3, it'd be 3x plus 2. Okay, so you're getting that fraction. Don't have that happening a whole lot, but recognizing that going from that fraction to that factor is a good, pretty important piece. Now, next thing we want to do is try to break down that quadratic that's left there. So I'm going to try to do X method on that. What goes on the top? 2 times 1 is 2. And we want it to multiply to be 4. Is there anything that multiplies to be 2 and adds to be 4? No. 2 times 1 adds to be 3. Gets close, but doesn't get there. Negative 2 and negative 1 adds to be negative 3. That's worse. So that doesn't factor. So if that quadratic doesn't factor, then I'm going to have to solve it by what? Quadratic formula. That's how I know to do it. I'm going to try that factoring every time because it makes finding the zeros really easy. But if it doesn't work, I'm going to set 2x minus 1 equal to 0, and I'm going to set 2x squared plus 4x plus 1 equal to 0. That's going to help me find the zeros. So that's my factored form. I'm just going to abbreviate that double F there for factored form. And then I'm going to solve those. I know this one's just going to be x equals 1/2. We've already done that. We know that. This one, that's where the work's at. That's where we got to earn our money here. So we got x equals negative b. So that's negative 4 plus or minus b squared minus 4 times a times c, all divided by 2 times a. We're going to try to work that out. So negative 4 plus or minus the square root. That'd be 16 minus 8, which would be 8. And then I'm going to try to simplify the square root of 8. It's 4 times 2 and 2 times 2. There's a pair of 2's. So that's going to simplify to be negative 4 plus or minus 2 radical 2. And I'm going to put each of those over 4 and simplify each fraction. So we got down to here. We had to break down the 8 because it wasn't a perfect square. Excuse me. And then, so we did the factor tree, 4 times 2, 2 times 2. We got a pair of 2's. That's the 2 on the outside. This 2 that's left over is the 2 on the inside. Then I split it into 2 fractions. Negative 4 divided by 4 is negative 1. 2 over 4 reduces to be 1/2, or square root of 2 over 2. So my zeros are 1/2 and then negative 1 plus or minus radical 2 over 2. Doing that quadratic formula is a big part of this. That factoring with the X method that we've been doing for a few weeks, that's a big part of this. All right. All right, so the next kind of step in progression here is we're not going to get a hint. So we got to learn to build our own hint. Okay? So they're not going to tell us what's a factor or what's a zero. They're going to say, okay, here's the polynomial, factor it completely and find all the zeros. So they're going to tell you to do that. And what you have to do, or what is helpful to do this, is what's called the rational zeros theorem. All right, so the rational zeros theorem, this is what it says. If a polynomial has rational zeros, Rational zeros mean numbers that can be written as fractions. That's what a rational number is. Remember we talked about that? It's been a way back in August and 1st of September, we talked about rational numbers being numbers that can be written as fractions. So rational zeros are zeros of a polynomial that can be written as fractions. That's what this is about. Okay? If a polynomial has rational zeros, then those zeros will be of the form P divided by Q, where P is a factor of the constant ends with the T, and Q is a factor of the leading coefficient. Okay. Now, on the quizzes, on the test exam 4, on the final exam, they always ask this. They want you to create a list of the possible rational zeros. Okay, so you got to be able to make that list. So we're going to take some examples. We're going to create the list, and then we're going to use that list. I'll teach you how to create your own hint. This rational zeros is the hint stuff. All right, so when we're looking at a polynomial, so let's just go into example F here. Here's our polynomial. F of x is equal to 6x to the 4th power minus 7x to the 3rd power minus 12x to the 2nd power minus 3x plus 2. Okay? This number is P. This number is Q. Okay? Now, P is the constant on the end. That's the number that doesn't have a letter. That's what constant means. The leading coefficient is the number in front of the highest power of x. Okay? Now, here's what we got to do to create our possible rational zeros. So, possible rational zeros. And if you Google this, you may see a website call it potential rational zeros. Potential, possible, same word. Okay? Possible rational zeros. We want the factors of 2 over the factors of 6. So what are the factors of 2? Those are the things that divide into 2 evenly. So the factors of 2 would be 1 and 2. Technically, we need a plus or minus on those because -1 would go into 2 and -2 would go into 2 as well. So put plus or minus in front of them. Now, on the bottom, we want the factors of 6. So we got 1, plus or minus in front of it, 2, 3, and 6. Anybody remember doing this in Algebra 2 in high school? That's where we do this. That's where we start learning this. Do this in Algebra 2. It's difficult, no doubt. All right, so now, that isn't the excuse me. Voice is running out today. All right, so that's just the start of making the list. To make the list, okay? So this is the actual list of possible rational zeros. Okay? So I always just write P over Q equals, and then I'm going to take the first factor on the bottom and I'm going to divide it into those two. So I'm going to have 1 divided by 1 and 2 divided by 1. So that's going to be plus or minus 1, plus or minus 2. That is 1 divided by 1 and 2 divided by 1. The next one, I'm going to take the second factor in the bottom and divide it into those two up there. So 1 divided by 2 is a fraction. That's 1/2. 2 divided by 2 is what? I already got that written, so I don't have to write it again. Okay? Now I'm going to go to the third factor on the bottom. 1 divided by 3, that's a fraction. That's 1/3. 2 divided by 3, that's another fraction. I don't have that written yet, so I'm going to write down 2/3. Then the next one, take the last factor or the next factor in the list there, and 6 goes into 1. Well, that's 1/6. 2 goes into 6, or 6 goes into 2, excuse me, 2 over 6. That reduces to be, 2 over 6 reduces to be what? 1/3. I've already got 1/3 on my list. I don't have to write it again. That means I'm done with my list. This is the list of the possible rational zeros. So I've taken my possible zeros from every number in the world down to a list of 12 numbers. If it has a rational zero, it has to be one of these 12. That's what the rational zero theorem does for us. Now, to get that hint, we've narrowed it down to one of these numbers. Or it may be more than one of these numbers. I don't know. We haven't worked it out yet. But what I'm going to do next is I'm going to utilize the graphing calculator. When I learned this stuff back when I was in high school in the 1900s, everybody didn't have a graphing calculator. What we had to do was we had to just make a guess on one of those 12 numbers and do synthetic division with it. If it worked, you made a good guess. You got a 0 in the remainder. If it didn't work, guess what? You mark that number out and try another until you find one that works. You guys live in a great part of life where you've got a graphing calculator in front of you. I'm going to graph the polynomial, and I'm going to see which one of these it hits the x-axis on. So I'm going to go to my calculator. I'm going to graph that. So after we get the possible rational zeros list, we need that because they're going to ask for it. Now I'm going to graph 6x raised to the 4th minus 7x raised to the 3rd minus 12x squared minus 3x and then plus 2. So that was the original equation. Now I see it crossing the x-axis. I type in that everything the right way there. 6x to the 4th minus 7x to the 3rd minus 12x. Yeah, I did. All right. I'm looking for it crossing the x-axis. Looks like maybe they're at 2. No. Did I type that in there? I know what it is. I miscopied my problem from the beginning. That should be a plus 7x cubed. On my notes, it's a plus, and I wrote a minus. I apologize. That doesn't affect our P over Q list, though. That's going to affect our graph. So I got to go back in my graph and fix that. Okay, so I'm going to go back to y equals, and I'm going to change that to a plus right there instead of a minus. Now, oh yeah, that's much better. I see it crossing in some nice places. I see it crossing in between some places. Okay, so what I want to do is find one of those that works and find an easy one that works. So I'm probably going to steer clear of the fraction ones first and get some of these that are nice whole numbers. So looking at where that's crossing the x-axis, what's a nice integer value where it crosses the x-axis? 1 or -2. Either one of those would work. I'm going to go ahead and do the positive 1 first. Okay? Jason, I had made a mistake when I copied that problem. That should be a plus 7x cubed in there, in that original problem. It doesn't affect our P over Q list, but it does affect our graph. So I'm going to use the positive 1 in synthetic division from that graph. So we graphed that. We found it crossing the x-axis at positive 1. It also crosses at positive 2, and we've got some places in between here that it crosses. That's probably one of those fractions out of that list. So we're gonna use the integers first. So I'm gonna do synthetic division with the positive 1 on the shelf first. So I've got 6, 7, negative 12, negative 3, and 2. You can't say 6, 7 in the high school, in case y'all didn't know, because it's because the kids can't handle it because of TikTok and like 6, 7. It's like they're in middle school. My 5th grader does it, and it's the most annoying thing in the world. If you do any problem that has a 6 and a 7 in it, it's chaos for 5 minutes. Yeah, I just try to say it as much as I can, because then it's not cool anymore once I start saying it. So I just try to say it as much as I can, and make fun of them when they say it. And, yeah, man, it's accepted. That's what they do. Anyway, all right. So we got that in there. Let's run synthetic on that. 6, that's 13. 13 and negative 12 is 1. That's a 1. That's a negative 2. There's a negative 2. There's a 0. Hey, great. So that tells me that x minus 1 is the factor. Okay? Now, here's the cool thing about breaking down a polynomial without the hints. When it was x to the 4th power to start with, what is the quotient going to end up being here? Is it x squared or x cubed? X cubed. That means I need to do synthetic division again. And the good news is I have another number that I can put on the shelf from my graph that's also in my P over Q list. What was the other nice number? Negative 2. So I'm going to run that with synthetic division. I'm going to put that on the shelf. I should get a 0 in my remainder when I do this. That'd be negative 12. That's a 1. That's a negative 2. That's a negative 1. That's a positive 2. There's the remainder of 0. That tells me that the factor is x plus 2. So what I've done is I've taken the polynomial and I've now factored it. You're using synthetic division twice. It factored as x minus 1, x plus 2, 6x squared plus x minus 1. And now I'm going to try to factor that quadratic that's left over. Multiply to be negative 6, add to be positive 1. Negative 3, positive 2. That adds to be negative 1. Yeah, swap your signs. That's okay. That's what we got to check for, because the most common mistake is not getting those signs right there. So I'm glad that came up, because we have to look for that. We got to look. So we got positive 3 and negative 2. I can't go straight to my factors because it's got that 6 in front. So I'm going to go 6x squared plus 3x minus 2x minus 1. And I'm going to group those. So that's going to be 3x, be 2x plus 1. And then out of the next group, I'm going to pull out a negative 1. So my factored form for that polynomial is x minus 1, x plus 2, 2x plus 1, 3x minus 1. There's my factored form. That's good news. Because it factored into 4 little pieces. So we took that big polynomial we started with, and we were able to break it into 4 small pieces that are easy to deal with. The zeros, we got x equals negative or positive 1. We got x equals negative 2. What's the 0 for 2x plus 1. Negative 1/2. And try again. Positive 1/3. Because that move that 1 by addition. Is that what you said? I'm sorry. I misheard. I thought you said negative 1/3. That's my fault. So there's my zeros. Notice all of these are rational numbers. They all could be written as fractions. And they're all in that list, that P over Q list that we found. Okay? If you find a rational zero and it's not in the P over Q list, either your rational zero is wrong or your P over Q list is wrong. It's got to be in there. Okay? So is the P over Q list required for you to be able to work these? No. But it is part of one of the things that I know they're going to put a question on the final exam. Sometimes there's been a couple of years where they put 2 questions about it, where you had to make that list on there twice. That's 4 points out of 100 on the final. That's really easy to do. So we want to be able to make that list, even though we've got the graphing calculator that kind of makes that list not really necessary always. Sometimes it's needed, sometimes it's not. So got to be careful with that, but we want to be able to make that list. So let's practice making that list as we work the next few problems here. So let's work example G here and see if we can do that. So here's the polynomial. G of x is equal to x cubed plus 5x squared plus 2x minus 8. Okay, I'm going to make my P over Q list. This one's easier because what's P? It's the 8 and negative 8 technically. What's Q? 1. So the factors on the bottom are just 1. So that means I don't have to have a whole big long list of fractions in there because I'm just going to be dividing by 1 the whole time. So my factors of 8 are 1, 2, 4, and 8. Technically, the factors on the bottom are plus or minus 1, and that's it. So my P over Q list is just going to be the top of that. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. That's my P over Q list. That's my possible rational zeros. Because if I divide them all by 1, they just stay the same. There isn't another number in there. So if there's a 1 in the leading coefficient spot, that makes your P over Q list really easy. So usually, like on the final, they'll have one of them that has a 1 on the front on the leading coefficient, and then the other question that they'll ask will have a different number there, like the last problem we did where it had like 6 in front. Okay. So now the next step, in order to get the hint to be able to do synthetic division with, is to do what with that polynomial? Graph it. So I'm going to graph that and run synthetic division with something. I hope it's something nice. It should be. So I've got x to the third plus 5x squared plus 2x minus 8. Hit graph. Oh, yeah. Some nice ones on this one. 3 nice ones, actually. So if they were just asking me for the zeros, could I tell you what they are without even doing synthetic division? Yeah. So that's a nice thing. We're going to go ahead and practice synthetic division here because we need that practice in breaking the polynomial down. But if they asked me for the zeros and I graphed it and I saw that, I can tell the zeros are at positive 1, negative 2, and negative 4. Those are all numbers in my list as well. Pick one of those to start with on synthetic division. That would be what I would pick too, because the math's easy with a 1, right? Drop the 1 down. And there's my remainder 0. What is the factor that goes with 1 being a 0?
X minus 1.
Yeah, x minus 1. So we have a 0 of 1. We have a factor of x minus 1. Okay? So That took my polynomial down from x cubed to x squared. That's right. So this is x minus 1 times x squared plus 6x plus 8. The good news is I can factor that other one by x method. And it's the shortcut x method, which is even better. What multiplies to be 8 and adds to be 6? 4 times 2. So that's going to be x minus 1, x plus 4, x plus 2. There's my factored form. What are my zeros? Yeah. 1, -4, -2. And if you put them in numerical order, bonus points to you, a million points tonight. And points don't matter tonight. But you don't have to put them in numerical order. Normally they're going to be in numerical order. Part of me is kind of flipping out because I didn't put them in numerical order right now. You just did it. Yeah, and that's fine. Absolutely. I usually do, but it doesn't matter if you do or don't. So that's definitely not numerical order. All right. So that's not bad. That's doable. We can do this. Let's get us another polynomial and see if we can break it down a little further. And I add a little to it here. Example H. Here's our polynomial. F of x equals x to the third power plus 9x squared plus 24x plus 20. Let's make our P over Q list. Maybe we can take a shortcut here on the P over Q list. Why can we take a shortcut on our P over Q list for this one? Yeah, because the leading coefficient Q is 1. So that means I'm not going to have to worry about doing any division here. I'm just going to get the factors of 20. What are the factors of 20? 1, 1, 2, 4, 5. I can't write that fast. And then 10 and 20. Yeah, that's it. Trying to keep up. My hand wouldn't work. All right, so there's our P over Q list. So we know that if it's got rational zeros, it's got to be in that list. We're going to graph it to find one of those to start with. So set up your synthetic 1, 9, 24, 20, and graph that thing and see where you start. We have x raised to the third plus 9x squared plus 24x plus 20. We're hitting graph. So we're hoping it lands in some good spots. All right, so this one's a little different. Notice how it hits the x-axis over here at -1, 2, 3, 4, -5, but it doesn't go through the x-axis at -2 there. It comes down to the x-axis and bounces off at -2. So there's something weird happening there. So let's kind of discover what's happening there. So I'm going to do synthetic division. I'm going to run it with the -5 because I know what's happening there. It's crossing the x-axis. I know that's a normal one. So I'm going to run with -5 here. And I'm going to drop that 1 and run synthetic division on that. And there's my remainder of 0. And it took the polynomial down from x to the third power down to x to the second power. Okay. So I have x plus 5, x squared plus 4x plus 4. That's my factored form so far of my polynomial. So we graphed this and saw it crossing the x-axis at -5. And then if we saw it doing something weird there at the -2, it's bouncing off the x-axis there. So that's doing something weird. So we wasn't sure what to do there. So we just went ahead and did synthetic division with the -5. And then we're going to see what's happening there by factoring that quadratic that's left over. So what multiplies to be 4 and adds to be 4? The same number twice. Ooh. So that's going to be x plus 2 and x plus 2. All right. So what that that's created is a repeated factor. All right. So the factored form on this guy can be rewritten as f of x equals x plus 5 and then x plus 2 squared. The zeros are x equals -5 and x equals -2, but this -2 has what's called a multiplicity of 2. Where do you think the multiplicity comes from? How many times it was a factor? The -2, x equals -2, we got that factor twice, so it has a multiplicity of 2. The -5 has a multiplicity of 1 because it only happened once. The factor x plus 5 was only there one time. Anytime you have a factor that's there more than once, it has a higher multiplicity. Okay? If the factor is there more than one time, it has a multiplicity. Okay? Now, the cool thing about the graphs is that you can see on the graph when it has an even multiplicity and when it has an odd multiplicity. So, make a note here. Zeros with an even multiplicity bounce or touch, means the same thing, the x-axis. Zeros with an odd multiplicity cross the x-axis. Even multiplicity, it bounces. I call it bouncing because to me it looks like the graph is going and it hits the x-axis and bounces off of it. Some books call it touching the x-axis. It just comes down and just touches it and leaves. Okay. If it's got an even multiplicity, it's going to bounce or touch. If it's got an odd multiplicity, like -5 has an odd multiplicity because it only counts once, and one is an odd number. So it crossed the x-axis. If we look at the graph of this, that -2 had an even multiplicity because it counted twice. Look at it. It's bouncing off the x-axis at that -2. That's where it touches the x-axis or bounces off of it. Jason?
At the synthetic division part, we pull that
Yeah.
-5.
Yeah.
Do you have to graph it to pull that -5, or can you just pull it off that P?
You could pull it off that P over Q list, but you're kind of just guessing if you're pulling it off that P over Q list. The graph really tells you which one to use out of that list.
I'm just trying to graph
Then you can guess a number out of that list, and if it doesn't give you a 0, then you got to start over. Yeah, that's where that comes from. Well, graphing, all you're doing is graphing it, just typing in the equation and hitting graph and seeing where it crosses the x-axis. So the calculator does make it a lot faster because you could end up guessing every number except for -5. So that'd be 2, 4, 6, 8, 10, 11, or well, actually take those 2 away. So 9 wrong guesses before you find one that works. That'd be terribly unlucky and probably not likely. You're probably going to stumble across the right one before you get to 9 of them, but it is possible that you could end up doing that. But yeah, you could do it that way. But I think graphing with the calculator is going to help you get there faster. All right, let's look at another example. Okay, we're getting close here. We got 1, 2, 3, 5, 6, 7, 8 more examples. All right, here's our polynomial. X to the 4th minus 7x cubed plus 18x squared minus 22x plus 12. So there's our polynomial. Let's get our P over Q list. Good news is there's a 1 in the front. So all I need are the factors of 12. One. What else? 2, 3, 4, 6, 12. So there's my possible rational zeros. Okay. So I'm going to, and here's how you know how much synthetic division you have to do. Look at the highest power of x. What's the highest power of x on this problem? 4. How many does it take to get that down to x squared? 2. I'm going to do synthetic division twice to get it down to something x squared. Okay, whatever the degree is, or the highest power of x, that is going to tell us how, take 2 away from that, and that'll tell you how many times to do synthetic division. So I'm going to try to find what to do with synthetic division. What do I use out of that list? So the easiest way to find that is to graph it. And see where it crosses or touches the x-axis. Hopefully it does somewhere. X raised to the 4th minus 7 x raised to the 3rd plus 18x squared minus 22x. What'd you say? Where's it crossing at? 2 and 3. Yeah. And that's the only 2 places. Ooh, that's different. Hadn't had that yet. Most all of them have had, it's crossed every how many times the highest power of x was. This time it's crossing at positive 2 and positive 3. Pick one of those to start with. It doesn't matter which one you start with. I usually start with the smallest number. I'll start with the 2. And I'm going to run synthetic with that 2. And then I'm going to run synthetic on the answer to that with the 3. Okay? So drop the 1. It's going to be -5. That's -10. That's 8. 16. That's -6. There's -12. There's my remainder of 0. So that tells me that x minus 2 is a factor. And now I'm going to run synthetic division on that answer with the 3 that I saw in the graph. Okay. Drop the 1 down. That's going to be -2. That's -6. That's 2. That's +6. That's a remainder of 0. That tells me that I have x minus 3 as a factor. Okay. So the factored form of my polynomial now is x minus 2, x minus 3, and then I have x squared minus 2x plus 2. And I'm going to try to factor that using the x method. Multiply to be 2 and add to be -2. Is there anything that multiplies to be +2 and adds to be -2? Only thing I could think of would be -2 times -1, but that adds to be -3. So that doesn't work. So it won't factor any further. So that means this is my factored form. Now I want to get the zeros. I got x equals 2. I got x equals 3. I already got those. Now I got to get the zeros for this quadratic that's left. And if it won't factor, how do I solve it? Quadratic formula, absolutely. So that's where I'm going to go with this. X equals -b plus or minus radical b squared minus 4ac divided by 2a. Okay. So I've got my quadratic formula written there, and I'm going to simplify this out. So this is going to be +4 minus 8 So that's going to be x equals 2 plus or minus the square root of negative 4 all over 2. There's a negative underneath my square root. That's where the complex solutions come in. So this is a complex solution. We've got the square root of negative 4 would be 2i, and then I'm going to divide each of those by 2. So that's going to be x equals 1 plus or minus I. Those are my 2 zeros. How many zeros do I have total? 1, 2. 1 plus I is the third one. 1 minus I is the fourth one. So I got 4. What was the highest power of x? 4. I need to be able to total up to be that same number. Every how many answers I have needs to match the highest power of x. If it doesn't, I'm missing something, or I've got a multiplicity happening. Okay, whatever the highest power of x is, that's how many answers I should be finding on my zeros. Doesn't necessarily mean that many factors, but it means that many zeros. All right. Now, let's change gears. We've been doing this a while. Let's change gears and do something different. Okay, within the same 2 sections here. Let's start with the answers and build a polynomial from it. Okay? So example J. Form a polynomial of degree 3 that has zeros of -1, +2, and 4 with f of 1 equal to 3. All right. So let's dissect what all this means. We're going to build a polynomial from those zeros. When it says degree 3, that means I should end up with x to the third power is the biggest piece of x I have. Degree 4 would be x to the fourth power. Okay? So the highest power of x is what the degree is. Okay? So I'm going to start out taking the zeros and I'm going to get the factors that go with them. So my polynomial, the factor that goes with -1 being a 0, what is the factor? X plus 1. What's the factor with 2? X minus 2. What's the factor with 4? Now, here is where that f of 1 equals 3 comes back in. Okay? There's going to be a leading coefficient. That's this a out here in the front. Okay? We're going to use this to find a. Okay? So I'm going to find a before I start multiplying all this together. Okay? So in this notation right here, the 1 is an x, the 3 is the y. So I'm going to set up an equation. I'm going to replace the f of x with 3. I'm going to replace all the x's with 1. And now I have some order of operations stuff to do. The order of operations says do parentheses first, so I'm going to add and subtract in those parentheses before I multiply. So that's going to be 2, -1, -3. And when I multiply those together, that's going to be 2 times -1 is -2 times -3 would be +6. So I've got 3 is equal to 6a. Now I need to get a by itself. Divide by 6, yeah. A is equal to 1/2. All right, so now I'm going to go to my problem, and I'm going to put in f of x equals 1/2 x plus 1, x minus 2, x minus 4. Now I'm going to multiply this stuff together. Okay? So this is the long, tedious part. I told you that this stuff, this section had some long stuff in it. This is probably the longest stuff in it. Okay? So I'm going to start, I'm just going to multiply, I'm going to pick 2 of them. It doesn't matter which 2 you pick to go together first. I'm going to pick these 2 for no real reason other than that's where I want to start. They got the bigger numbers in them, so that's why I picked them. Okay? So I'm going to multiply these 2 together first. So x times x is x squared minus 4x minus 2x plus 8. I still have the 1/2. I still have the x plus 1. I'm going to simplify that parenthesis. Get x squared minus 6x plus 8. Now, I'm going to multiply this x plus 1 times all of that. So I'm going to distribute the x. X times x squared is x cubed. X times negative 6x would be negative 6x squared. X times 8 would be plus 8x. Then I'm going to distribute the plus 1. That's plus x squared minus 6x plus 8. Put parentheses around that. The 1/2 still hanging out there. Hadn't done anything with it yet. We're about to, though. After I simplify this, I can then distribute the 1/2. So I'm going to simplify this one. I'm going to have the 1/2 times x cubed minus 5x squared, because negative 6x squared and positive 1x squared makes negative 5x squared. And then positive 8x and negative 6x would be positive 2x. And then we got the plus 8. We are one operation away from, or one step away from finishing this problem. So I'm going to distribute the 1/2 to everything in the parentheses. That's the last step. And finally, we're done. So the last step, f of x equals 1/2 x cubed minus 5 over 2 x squared plus 1x plus 4. And there I have my polynomial that has zeros of -1, 2, and 4, and goes through the point 1, 3. That's tough. It's long. Okay. Let's do another one of those. Do one that's a little bit easier. Or maybe shorter, I don't know. Here are our zeros. -2 with a multiplicity of 2 and 3. And I'm going to be nice and let a equal 1, so we don't have to deal with that a stuff on this one. So let's build a polynomial that has -2 as a 0, that has multiplicity of 2, and 3 is a 0. So let's build the factors. What's the factor for x equals -2? X plus 2. How many times is that a factor? Twice. I'm going to write it 2 times. I'm not even going to write the step where I put a squared on that, because I'm going to have to write it out twice anyway. What's the factor for the 3? It's -3. Boom. Then I'm going to multiply together. I'm going to do these 2 together first this time because they're the same thing. Well, maybe I can get that together. It doesn't matter what order you multiply them together in. You pick whatever order you want to. This is the order I'm going in. So x times x is x squared plus 2x plus 2x plus 4. And I still got the x minus 3. We'll simplify that parenthesis there. I got x squared plus 4x plus 4. And I got x minus 3. And now I'm going to distribute. I'm going to distribute the x minus 3 to the 3 terms instead of the 3 to the 2. Just because it's shorter. It's the same, but it... So that's going to be my x to the 3rd power, 4x to the 2nd power, plus 4x. Then I'm going to distribute the negative 3. Minus 3x squared, minus 12x, minus 12. Now all I got to do is put my like terms together. So I got x cubed. I've got a 1x squared. I got a negative 8x. And then I've got negative 12x and negative 12. So here we've had them with rational zeros there. Now let's get one. Yes, ma'am. That should be an x squared. Well, hold on. All right, so we got x, the x squares, the 8x. My brain was not on the right thing there. Sorry. So we have 4x squared and negative 3x squared. That's 1x squared. 4x and negative 12x. That's the negative 8x. And then that should just be a negative 12. I'm sorry, I wrote negative 12x twice there. That should be the final answer. Thank you for being engaged. All right, let's do one that's got a square root in there. Okay, because you need to be able to see that. So here are our zeros. 3, and then the square root of 5. They will give you that as the zeros and act like they didn't cheat you. But they cheated you out of one of your zeros. Because a square root in a zero, there is the square root ones had to have come from either taking a square root to solve or using quadratic formula. What is always in front of the square root in the quadratic formula? Plus or minus. So they told us that was the only zeros, but there's another one that we know about. It's actually negative square root of 5. This one is, this is the sneaky zero that they don't tell you about. They didn't write it in the problem, but it's there because if positive square root of 5 is a zero, then negative square root of 5 has to also be a zero, because anytime we got a square root, there's a plus or minus in front of it. So that's why that negative has to be there. Okay, that negative square root of 5 has to be there. Okay, so you've got to, when you get a problem like that, if it's got a square root in it, then you got to know, hey, whatever that is, I got the opposite of that too. If it's a positive square root of 5, I've got the negative square root of 5. It's a negative square root of 3, then I got the positive square root of 3 as well. Okay, so you get that extra zero that you have to put in there. So then you build your factors. X minus 3, x minus the square root of 5, and x plus the square root of 5. So the x minus the square root of 5 is coming from the positive. The x plus the square root of 5 is coming from that minus. Opposite sign there. Now we're going to multiply that together. Okay. So I'm multiplying these two together first because they got the square roots in them. I think something weird happens with that. So I'm going to multiply. X times x. Yep. And then x times radical 5 is just going to be x radical 5. And then we're going to multiply x times negative radical 5. So that's negative x radical 5. And then negative radical 5 times positive radical 5 is negative radical 25. Okay. What happens to the radical 5s in the middle? Yeah, one's a positive, one's a negative. They're going to cancel each other out. What is the square root of 25? Oh, okay. So that's really just x squared minus 5 times x minus 3. Well, that's a lot shorter than what we've been doing. That's a lot easier. That's good. But we need a break here. So let's multiply x times x squared. That's x cubed. X times negative 5 is negative 5x. Now, negative 3 times x squared is negative 3x squared. Negative 3 times negative 5 is positive 15. Now, all I got to do is put it in the right order. X to the third minus 3x squared minus 5x plus 15. And there we have built a polynomial that had rational zeros to it. Okay. All right. We got one more build a polynomial example. And then we'll get to the end behavior, which is one of the easiest things we do. Okay. Let's build a polynomial. Here are our zeros. Negative 4 and 2 minus I. Now, got to keep in mind, where does an I come from? A negative square root. So the same rule applies to this as applied to example L, because that I came from a square root. So we know that that actually should have had a plus or minus in front of it. So the sneaky 0 is going to be 2 plus I. So that one's the sneaky 0. They didn't tell us about it, but because we're smart and we know that the I came from a negative square root, that it had plus or minus in front of it. So that is got to be in there. So this one, a little bit more complicated as far as multiplying it out. Building the factors, though, is the key. The factor for negative 4 is just x plus 4. That's easy. The factor for 2 minus I is going to be x minus 2 plus I. Swap the sign on both. The factor for 2 plus I is going to be x minus 2 minus I. Swap the sign on both. And now we got to multiply all this out. The good news is that the I stuff should cancel out. Okay? So when I multiply all this out together, the I stuff should cancel out. So I'm going to multiply x times x. That's easy. That's x squared. X times negative 2 is negative 2x. And then x times negative I. That's negative ix. Okay? Now I'm going to multiply negative 2 times all of that. So that's another negative 2x. That's a positive 4. That's a positive 2i. So that's multiplying negative 2 times all of that. That's what's written in red there. Now I'm going to multiply I times all of that. I'm going to write that in green. So I times x is ix. I times negative 2 is negative 2i. I times negative I would be negative I squared. All right. So I still got the x plus 4 in the front there. Hadn't done anything with that yet. Now, inside of this parentheses, let's start canceling out stuff. I have a negative ix and I have a positive ix. They're going to cancel each other out. I have a positive 2i, I have a negative 2i. They're going to cancel each other out. I have a negative 2x and a negative 2x. They're not going to cancel each other out, but they're going to go together to make negative 4x. So I have x squared minus 4x. Now I've got some other stuff in here. I got a positive 4 and I have a negative x squared. What do we remember that x squared is equal to? Negative 1. X squared is equal to negative 1. So this is really negative 1. What is double negative on that? Positive 1. So what is 4 plus 1? It's 5. So that's what that simplifies. And notice it doesn't have any I stuff in it anymore, because none of our polynomials had I stuff in them to begin, when we started earlier. So they don't have I stuff in them anymore now. Now we've done the hard part. This is the really difficult part, getting that done. Now we just got to multiply this x plus 4 times that quadratic to get our polynomial. Zoom back out there. So x times x squared is x cubed minus 4x squared plus 5x. Then multiply 4 times all that. So that's a positive 4x squared. That's a negative 16x. And that's a positive 20. And then combine your like terms and you get your polynomial. X cubed, these two cancel each other out. That's a negative 11x and plus 20. And there's our polynomial. Very tedious work, a lot of operations in that. But if you take it slow and don't try to rush your way through it, don't try to do too much at a time, then you can get it done. It just takes being patient with yourself and making sure you get your signs right. Okay. All right. The last thing that we're going to talk about of the semester, okay, last new thing, is the end behavior of polynomials. This takes no multiplication. This takes no i's and no square roots and no division or anything like that. It just takes looking at a polynomial. Probably one of the easiest things we do. The end behavior of a polynomial. So I'm going to make a little chart here. We got the degree. That's our first column. We got the leading coefficient. Spell coefficient correctly. Coefficient. In the second column, then we got the left side. We got the right side. And then I'm gonna draw a little sketch over here. And just a small picture. All right. So the degree, remember, is the highest power of x. Okay. There's only two possibilities. It's either an even degree or an odd degree. If it's an odd degree, Odd degree would be x to the third power, x to the fifth power, x to the seventh power, something like that. Odd number is the highest power of x. If it's an odd degree and it has a positive leading coefficient, the left side is going to go down, the right side is going to go up. There may be more humps and valleys in the middle, but it's going to look something like that. The left side going down, the right side going up. Odd degree, positive leading coefficient, left side down, right side up. Notice that the ends are going in opposite directions. Left side down, right side up. Odd degree starts with an O, opposite starts with an O. Okay? If it's an odd degree and a negative leading coefficient, flip them. Left side's going up, right side's going down. Gonna look something like that. I didn't do as good a job drawing my little polynomial there. Kind of got sharp on the corner there, but that's okay. Those are the only two situations for an odd degree polynomial. Okay? Next possibility would be an even degree with a positive leading coefficient. Both ends are going to go up. If it's even degree, the ends go in the same direction. Positive leading coefficient, both go up. You think about a positive person, they always look on the upside of things, right? Even degree, both ends go the same direction, they both go up. The polynomial graph might look something like a W or something like that, but both ends are going up. That's the main thing. If it is even degree with a negative leading coefficient, guess which way they go? Yeah. Looks like a hymn. At this point, I know we're all hungry. It's like the golden arches, except for you folks that already ate today. Didn't bring us none. All right. So let's look at a couple of examples of equations. And all we're doing is deciding what the degree is. Is it even or odd? And what's the leading coefficient? Then that decides the end behavior. That's all we have to look at is the first term to decide that. Everything else makes the humps and the valleys and stuff. The first term tells us exactly what we need to know as far as end behavior goes. Okay? So let's do example, I think this is N. Describe the end behavior. Here's our function. F of x is equal to 3x to the fifth plus 816x to the fourth minus 512x squared plus 863. The only thing that matters in that whole polynomial is this thing right here. None of the rest of it matters as far as end behavior goes. Degree is odd. The leading coefficient is positive 3. In my little chart, what does an odd degree with a leading coefficient that's positive do? What does the left side do? Left side down, right side up. We got the end behavior. Isn't that one of the easiest things we've done all semester? It's a good thing to end on. Let's do one more. The donut example is a good one to end on. You can put your sprinkles on your donut if you want to. I'll put on some red sprinkles, a little bit of patriotic blue sprinkles. All right, so here's our polynomial. F of x equals negative 6x to the fourth minus 65x cubed plus 112x squared minus 5x plus 1,760. What part of that matters when it comes to end behavior? That is the only part that matters. The rest of it does not affect end behavior. Only the biggest power of x. So that is an even degree. So we know both ends are going to go the same direction. The leading coefficient is negative 6. So what direction does an even degree and leading coefficient that's negative go? Both of them are going down. You need to have that chart memorized so that you can do that on the test, on the quizzes, and on the final. They ask that kind of question on the final. They usually pick graphs that are so big you can't graph them with the calculator. That's why I'm trying to show you this. Skylar. Which one? The chart? Yeah, there you go. So enjoy your Thanksgiving break. We will not meet next week. If you have any questions during that time, feel free to email me. Shoot me a message through Canvas. I'll try to help you. And then I'll see you December the 1st for exam 4 and the last labs. I'll send out the review and everything. It'll probably be tomorrow before I get that sent to you. But you'll have 2 weeks to do everything that's assigned for today. Okay?